Hello, welcome to another Parker podcast. We are looking at projectile motion and how to do some basic problem solving. We're going to be looking at a projectile that's launched at a certain angle and lands at its same height. Any projectile we can break into X and Y components. The reason we do that is so that we can do a full analysis, because we know that Vx does not change with time, but Vy will initially shrink. When it gets to the top, Vy will begin to grow. And it's only by breaking it up into these two component parts that we can then analyze what the velocity is at some time, or how long it takes to get somewhere, or how far it goes, or how high. That is the only way to do it. So, what is special about the position when the projectile is at the very top? Well, we know that the velocity at the very top, the velocity in the y direction, is 0. Therefore, but since Vx never changes, that means that the actual velocity of the projectile at the top will be equal to Vx. How about down at this position? What are we going to know? Well, Vx doesn't change, so it's the same as it was at the beginning. However, at this point, the velocity that the projectile lost is going up, it gains coming back down. So the velocity in the y direction at the very end, right before it hits the ground, is equal to the negative of the initial launch velocity in the y direction. So we're going to keep these facts in mind when we move forward in solving this next problem. We have how the variables change with time, and also our basic velocity, or our basic kinematic equations for projectile motion. So here's our problem. Tom Brady, of course, throws a perfect pass. It is launched with a velocity of 24 meters per second at an angle of 38 degrees. And the question is, what is the horizontal displacement, or the range, and what is the maximum height? And of course, we're assuming that the ball was caught at the same height that it was thrown. So what are the things that we know? Let's tackle the maximum height first. So here's the situation. Ball is thrown at some angle with some velocity, and we are trying to figure out what is this maximum height. And the things that we know is that Vy is equal to 0. So we're going to look at this in terms of the X components and Y components.
Call 4803. Eric Williams, 4803.
Right. Eric Williams, there you go. Since we're concerned primarily with the Y direction, we're not going to analyze anything in the X direction for this. We're just going to go with the Y direction. We know that V0Y is equal to V0 cos theta. The velocity at the very peak is 0, and we're looking for Y max. What equation has these three variables in it? V squared equals V0Y squared plus 2GY. We're going to solve that. Well, I'm not going to plug in any numbers except for one. I'm going to plug in that 0. Instead of Vy, I'm going to have 0. So then I want to solve this equation for Y, because I can know what V0Y is. I know what G is. So this, I'm going to subtract 2GY from both sides, and I know that G is negative 9.81, so that negative is going to end up going away. So I'm just going to drop it right now. I divide both sides by 2G, so I get Y is equal to V0Y squared plus 2G. I'm sorry, divided by 2G. This is the maximum height. This is the equation that will tell me what. So the next step is that Y, I'm going to relabel that as Y max. So Y max is equal to V0Y squared, but instead of V0Y, I can put in V0 sine theta. That comes from this, which is wrong. That should say V0 sine theta. So please fix that in your notes. So this is V0 sine theta, and that whole thing is squared, and it's divided by 2G. When you put this in your calculator, you're going to want to make sure that you put a parenthesis around that. So let's take a look at how this is going to appear in your calculator. Let me zoom to a more appropriate level. Okay. So Y max is equal to V0, which is 24. Oh, that should not be cosine. That should be sine. See, even Parker makes mistakes. Okay, so I'm going to put a parentheses. 24 times the sine of 38. End the parentheses and square that whole thing. And then I'm going to divide that by 2 times 9.81. Now you have to put the parentheses here. 2 times 9.81. Otherwise, the calculator is going to misinterpret what you are intending. So we have a maximum height, y max, of 11.1 meters. Now, what about finding the horizontal displacement? Well, we need to figure out what are the things that we know about the projectile when it has returned back to Earth so that it's at the same height that it started at. Well, that means delta y, the change in height, is equal to 0. And also that the velocity it lost, it has regained. So Vy at the very ending point is equal to negative V0y. We're going to use those facts in solving this problem, and I'm going to go to paper now. So here it is. I know that V0, I'm given V0, I know the angle, and I'm trying to figure out what is a horizontal displacement. So that's why I'm analyzing the projectile at this point, and I know that delta y equals 0 and Vy is equal to negative V0y. I break it up into the x and y directions. Always start with these, can't go wrong there. I want to find x. There's only one equation that has an x in it, x equals Vxt, and I can know what Vx is. Slight problem here, I don't know what t is. So I'm going to have to go over to the y direction to find t. So what are the things that I know about y in this position where I'm looking for x, where I want to find the time it takes to get to? I know that delta y equals 0. What else do I know? I know V0y, because it's just V0 sine theta. And I'm trying to find t. T equals question mark. So what equation is going to have these three variables in it? And it's going to be this equation here. I know that delta y is equal to V0yt plus 1/2 gt squared. And that delta y is going to go away. It's going to be 0. So this is 0 equal to V0t plus 1/2 gt squared. Now remember, you can learn how to derive these equations and you can solve the A+ problems, or you can just memorize the end equation that I'm going to end up giving you. I'm going to subtract 1/2 gt squared from both sides. I'm going to get minus 1/2 gt squared is equal to V0yt. And again, that g is negative, so I know that this negative is going to go away because of the negative 9.81, so I'm just going to make that a positive now. I'm going to multiply both sides by 2. I'm going to divide both sides by g, and I'm going to divide both sides by t. So I divide both sides by gt, and that gets rid of this t over here. This t gets rid of that square. These g's go away. So I have 1/2 t is equal to V0y over g. I'm going to multiply both sides by 2, and that gets rid of this 2 here. So in the end, what I have is t equals 2 V0y over g. And V0y, remember, is V0 sine theta. So our t equation is going to be 2 V0 sine of theta all over g. So basically, that is the time it takes for the ball to return to the same height from which it was launched. That's this equation here. So this is a good equation to memorize if you are not one who wants to derive it. Now we're actually going to put in our numbers. So that is 2 times V0, which was 24, times sine, the angle was 38 degrees, and then we're going to divide that by 9.81. Not negative 9.81, we got rid of the negative with the algebra there. So we have 3.0124, you know what, we'll just round that to a time of 3.01 seconds. That is the time that I'm going to be applying over here. So x is going to be equal to V0 cos theta t, because I'm substituting this up here for this. X is equal to that. X is equal to 24 times cosine 38 multiplied by 3.01. So I can put that into my calculator. 24 times cosine 38 and the parentheses times 3.01 gives us a horizontal displacement of 56.93 meters. If I apply my sig figs, that gives me 57 meters. That's my horizontal displacement. Now, there's more than one way to skin a cat. We can solve this knowing some other information. Remember that, all right, delta y is equal to 0, but also Vy is equal to negative V0y. We can use that fact to solve this equation. This is just a different way to do it. I can start with Vy equals V0y plus gt. But what do I know about Vy at the point where I want to solve for the time? It's equal to negative V0y. So I can substitute negative V0y is equal to V0y plus gt. Solve that equation for t. I'm going to subtract or add this to both sides and subtract that from both sides. So I get minus gt is equal to V0y plus V0y. I have two like terms here that I can combine into one term. Minus gt is equal to 2 V0y. Remember that g is going to be negative 9.81, so that positive ultimately will become, or that negative will ultimately become positive. I'm going to divide both sides by g. So t is equal to 2 V0y over g. Now here I had a different approach. I ended up with the same equation. So that's just another way to do it. And that's all you need to know in order to solve these projectile motion equations. Or I should say the projectile motion equations for a horizontal launch, you have these two. For a launch at an angle, you have these three. And again, remember that these ones only apply to this situation. These ones only apply to this situation. If you are smart, you will figure out how to be able to derive these equations so that when you are faced with some of the more difficult problems, you will be able to derive any equation you need. So one hint I would give to you is to memorize, or not memorize, but remember how to derive these equations. Practice deriving these equations starting with the stuff that you know about these situations, and these equations always work. Always work for every situation. These ones are only specific to these particular situations and positions. But if you are able to derive these equations, again, no problem is close to you. You can figure anything out. But that's it. That's all she wrote. And I will see you on Tuesday. Have a great weekend. Take care. Bye.